Let's get cracking today. This was the homework that I had put up last time. So I've kind of started it here on the left and finished it on the right-hand side. So I'd like you to take a screenshot of that, and then you can go and compare it to what it is that you did and see how that went. We will obviously have some kind of session where we'll be able to do a catch-up and talk about these sorts of questions and, yeah, just kind of touch back on the homework. But unfortunately now I've got to get started on similarity. So yes, please take screenshots, and then I'm going to go onto the similarity page. So I'm just going to wait a couple of seconds, and then I'm going to move over. Just give everybody a chance to take a screenshot. Okay, so we should all be done by now, theoretically. I'm going to go onto the similarity page, and we're going to jump up to the top over here. Okay, so we have finished speaking about the proportionality intercept theorem for now. I wanted to touch on similarity, which is the other big concept in matric that's going to be new to you guys. And this is something that your teachers should have done with you in grade 9, but I mean, it's such a long time ago and we forget the things that we learned. So, you know, you probably are going to be a little bit rusty. So let's just start with the basics. Specifically in maths, when we are speaking about triangles and we say that triangles are similar, what exactly does this mean? Can anybody remember? Anybody got any ideas? What does it mean? It has a very specific meaning in maths when we say that triangles are similar. Anybody want to offer an answer? What does the word similar mean when we're talking about triangles? It's similar to congruency, Fahim, but it's not exactly the same as congruency. So I'm actually going to write there congruency, and we can compare that to what we're talking about here with similarities. They're not exactly the same thing. Similarity and congruency are a little bit different. Anybody know what it means when we say triangles are similar? You're welcome to unmute if you've got an idea you want to share. Bradley says they look the same but not equal in length. Perfect. Nampumelelo, you're on the right track. Okay, so same sides of a triangle. Equiangular, yes, absolutely. So a lot of these things that are coming from you guys here is 100% correct. So when triangles are similar, let's just formalize this a little bit. It means, okay, that they are the same shape, but, whoopsie, different sizes. So what we will see is a triangle that, let's say, perhaps is shaped like this, and then another triangle that's the same shape, but it's a little bit bigger. So if this angle over here, let's say that's 90, and this one over here is 50, and that one over there is 40, then we would see exactly the same thing in this triangle over here. So the word equiangular is sort of correct. Equiangular strictly means they're all 60, but I know what you were trying to say, all the angles are the same. Okay, so all the angles are the same, but they are different sizes. Okay, so the lengths of the sides are different. Okay, but all the interior angles are the same size. The other thing that it means when we say the triangles are similar is this, is it means that their corresponding sides are in the same proportion. Okay, so let's just break this down a little bit further. How do we know which sides are corresponding? What is the meaning of the words corresponding sides? What are we talking about exactly over here? Does anybody know how we would figure out what are the corresponding sides in triangles? Anybody know how we would figure out what the corresponding sides are in different triangles?
Come on, my pips, let's dog those memories. Let's go. I'm sure y'all are thinking now.
Amokilani, go for it. You've got your hand up.
Ma'am, I think corresponding sides means a pair of matching angles or sides that are in the same spot in a different shapes.
You're on the right track. Okay, but more specifically, when we talk about corresponding sides, and I'm going to write it here for you guys so that you know this, corresponding sides are opposite angles of the same size. So if I call this side A and that side B and that side C, and I call this side D and this one E and this one F, okay? Can you see that side AB and side DE are both opposite the angle which is 40 degrees in their respective triangle? So I would say that AB and DE are corresponding sides. Similarly, AC is opposite the angle that's 50. DF is opposite the angle that's 50. So in this situation here, I would say that AC and DF are corresponding sides. Okay, so their corresponding sides are opposite angles of the same size. So that's really important to us. And then when we say they are in the same proportion, we're going to talk a little bit more about that. So what we know about proportions is going to be important for us. Okay, so remember, a proportion is a relationship where we have something over something else, which equals a different value. Okay, so the numerators are not equal, the denominators are not equal, but they're in the same proportion, because if I simplify the fraction on the right-hand side by dividing both the top and the bottom by the same thing, I'm going to end up with this. Okay, but it does not mean that the numerators are equal and the denominators are equal, because they're not necessarily equal to one another. Okay, all right. Let's just have angles which are formed in matching corners. There we go. Okay, so let's just go down here a little bit. And we are, as Yolanda says, don't forget to take screenshots. Let's move on and talk now about how do we prove that triangles are similar. Okay, so a huge part of what we're going to be doing is proving that triangles are similar. Can anybody remember how we prove that triangles are similar? There are only two ways to prove similarity. There are two ways it can be done. Anybody remember what that is?
There's no wrong answer, my people. Let's go.
There we go. William, same angles. Lovely. Teddy, proportionality. Okay, parallel and perpendicular, not with these types of triangles, no. All right. The first way is to prove angle, angle, angle. So in other words, what you are doing is that you are proving that three angles in one triangle equal three other angles in the other triangle. The second way that it can be done, well, let's have a look what you are saying in the chat. There we go. Annie, that's a lovely definition. If the corresponding sides of two triangles are proportional, then the triangles are similar. Very nice. I could not say it better. Okay, so that in a nutshell is you are proving that the corresponding sides, and we know what corresponding sides means now, corresponding sides are in the same proportion. Okay, so that is if we knew about the lengths of the sides. So we would do this when we are working with angles, and we would do this if we were working with sides. So in today's lesson, we are only concerned with angles. We're not going to be talking about sides in the same proportion, although that will, or proving triangles are similar by using corresponding sides. We're going to worry about that in our next lesson. So let's jump into an example, and I can show you what it is that you need to look at and how all of this is set out. Okay, so if we have a look at this, they've told us in triangle PST, so that's the big triangle, TS is perpendicular to PS. And R cube is perpendicular to PT. What does that mean? If they tell us that one line is perpendicular to another line, what does that actually mean for us? What are they telling us? They're telling us something about an angle. What are they trying to tell us? What does this mean for us? Anybody know? So if they tell us that TS is perpendicular to PS, what does that mean? There we go, Nolwazi, very nice. Yes. So they are telling us the angle at S is equal to 90. Very good. Similarly, if they tell us that RQ is perpendicular to PT, what do they mean by that? Yeah, there's a right angle in the triangle. Absolutely. S1 plus S2 is 90. Fantastic. So over here, if RQ is perpendicular to PT, it means that angle QRT, or I could say TRQ, is also equal to 90. So what we would say in this situation over here is that this information is given. This is given information. So if we were to use this, we could use the word given as a reason. The first thing that they want us to do with this little bit of information is to prove that triangle PRQ, so let's go and highlight that. So PRQ, is this triangle over here. Oh, sorry, it's still a bit skew there. That PRQ is similar. Remember the symbol for similar is three straight lines that sit next to one another, to triangle PST. Okay, so now I'm going to go and highlight PST as well. So PST is this big triangle. And there it is. And what we can see in this situation is that our purple triangle sits inside our yellow triangle. Not exactly, okay, but it sits inside. So what they're telling us is that these two triangles are the same shape, but they are different sizes, right? So what they want us to do is think of three reasons when it comes to angles why these angles are equal, all right? But before we jump into that, I need to point out something to you, all right? And this is really, really, really important. R1, I'm just having a look. Tundle where to? R1 plus R2 is also equal to 90. In this case here, if you add angle R1 to angle QRT, you get 180. All right, so if what you're trying to say is that R1 is equal to 90, then absolutely I agree with you. And that would be because of adjacent angles on a straight line. Okay, so before we actually jump in and start talking about how we would prove similarity, I want to point out to you that when they give you the triangles that you are proving are similar, please can we mute? Thank you. When they tell us which triangles to work in, they are giving us very, very important information. All right. So when we write an angle in maths, right, we can either use three letters, but most of the time we use one letter. So if they say to us triangle PRQ, that means that P is an angle, R is an angle, and Q is an angle. The other thing that they are telling us over here is that it's triangle PST. If we put two letters together, so I talk about PR, if I put those two letters together, that is a side of a triangle. Just like PS is the side of a triangle. The order is very important. The first letter that happens here, so this P over here, they are telling you that angle P in triangle PRQ is the same size as angle P in the second triangle. They are also implying that angle R in the second triangle is the same size as angle S in the other triangle. And it's the same with angle Q as well. Angle Q in the first triangle is the same size as angle T. So the order in which we write our letters is very, very important. Okay, so the angles that are the same size have to go in the same order. All right, and the reason that this is important is because then the corresponding sides will also be in the correct order. Now the sides correspond as follows, right? The first two letters, which make up side PR in the first triangle, corresponds with side PS in the second triangle. The second two letters, so R and Q together, R and Q corresponds with ST in the second triangle. And first and last, so in other words, side PQ in the first triangle corresponds with side PQ, sorry, I beg your pardon, PT in the second triangle. Okay, so the order of the letters is very, very, very important. When we set our proof out, okay, we need to do it in a specific way. We need to write in triangle PRQ and PST. And then we're going to look for our first reason, okay, which we've already been given. We know that angle R1 equals 90, and we know that angle S equals 90. So look here, there's angle R, and there's angle S. Can you see how they're both in the middle? They're both in the same position in terms of the order of the letters. All right, so they're telling us angle R1 is equal to angle S. What was our reason here? They're both equal to 90. This was given. Okay. The second thing, you need to find another reason now, right? So we've done this one, we've done R and S. What can we say about P and P? If we have a look here, what could you say about angle P in the purple triangle and angle P in the yellow triangle? There's a word that we use for that. There we go, lovely. Okay, it is common, it is a common angle, quite right. Okay, so angle P is common. Now, the other very important thing is that when you are proving similarity, you only need to prove two angles, okay? After that, the third angle can always be obtained by using angles of a triangle. Remember, the angles in a triangle add up to 180 degrees. So if we have got triangle P plus angle P plus angle R1 plus angle Q2, and that adds up to 180. And in the other triangle, we've got angle P, and we've got angle S, and we've got angle, what was it? It was called T. And that adds up to 180 because of angle sum and triangle. These two are the same. These two are the same. What they add up to is the same. So that means that angle Q2 has to be equal to angle T. So you can only use this reason, angle sum and triangle, as your third reason. If you use it in number 1 or in number 2, you're not going to get any marks. Okay, so here we can say that angle Q2 is equal to angle T, angle sum and triangle. Okay, the other thing that you might see your teachers using here, your teachers might use the words remaining angles of triangle as well. Okay, but this over here underlined in green means that the angles of a triangle add up to 180. So if they tell you the triangle, which triangles are similar and what you need to prove, they're actually giving you the answer. You just then have to go and look for the clues, all right, and try and figure out why P equals P or why R equals S or why Q equals T. Done that, P equals P or why R. Triangle PRQ is similar to triangle PST, and our reason would be angle, angle, angle. Okay, what I'm going to do is I'm going to stop there and I'm going to ask you if there are any questions before I go on. Are there any questions you guys want to ask?
Ask or forever hold your breath, guys. Let's go. Ask questions. Take screenshots. Uh-oh.
From
Amasha,
where
you must have gotten something. Yeah. From which part?
Okay, so let's do it like this. I want you to give me, okay, from part B. Okay, all right. Is there a thumbs up or is it a thumbs down at this point?
Let's vote, my people. There's 83 of us. Let's see.
Can you give me a thumbs up or a thumbs down? And please don't feel afraid to put a thumbs down. I need to really know how you are feeling.
Yeah.
Okay, Amahle is not happy. Thanks, Nwazi. Okay, Nompumelelo, I see you. Okay, Omkholo. Bonolo. Dokazani's okay. Okudo's okay. I'm sideways.
I love the explanation of sideways.
Thanks, Fahim. Okay, so there's sort of a real mixture of response here. So now, Itandile, I see you say from B. I haven't done B yet. I'm just busy with question A. I'm just proving that the triangles are similar. I haven't done question B and I haven't done question C yet. So I was just explaining this entire explanation that's here on the board is all about me doing A. All of this is A. Okay. Yes, go for it, Itandile. Ask your question.
You can unmute Itandile and then talk to us.
Hi, ma'am.
Hi there, how are you?
I'm good, and you?
I'm fine, thank you.
Okay. I didn't understand the first, the R angle R1 is equals to angle S. I quite didn't understand how we got to the answer because of my network. Like everything's busy.
Okay, so it's not because you, so you were just in and out, in and out, in and out. That was the reason why it was a little bit difficult. Okay, all right. What I'm going to do, let me just see if I can do this. I was just thinking if there was a question that I could give the people that were feeling confident to do while I re-explained this, it would be quite nice. Let me see if I can work some magic here. Okay. Let's get rid of that. Let's see what we can do here. Okay, so those of us that were feeling confident about what it is that I just said, I want you to have an opportunity to practice what I'm saying. So what I'm going to do is I'm just going to copy that and I'm going to pop it over here. Right. Let's just move this over there. Okay, so Does that work? Is it 2? Okay. If you are feeling confident, all right, and you would like to try this by yourself, I want to give you the opportunity to do that. So those of you that put a thumbs up and said you feel good, I want you to read this information over here, and I want you to try this question. Okay, question A, you're going to try and prove that PAB is similar to triangle ABC. Those of us who are confused, I'm just going to go through triangle PRQ and PST just one more time. Okay. So the best thing that you can, so those of you that are confident, you can get started. Those of you that want to listen to me, I'm starting now, okay? It's important for us before we begin to read all the information that's given. They told us we have lines that are perpendicular. So the minute they tell us that we have lines that are perpendicular, it means that we have angles that are equal to 90. So in other words, they're telling us that this angle over here is equal to 90 and that angle over there is equal to 90. Angle S is in the yellow triangle, but this pink angle over here is not in the triangle. But because adjacent angles on a straight line add up to 180, it means that R1 is equal to 90 as well. Okay, so R1 is equal to 90 because of adjacent angles on a straight line. Okay. So that can be a starting point for us. We know that R1 and S are going to be the same size. So when we set it out, we say in triangle PRQ and triangle PST. Okay, now we're looking for one angle in PRQ that's the same size as another angle in PST. So we know because R1 is 90, and S is 90, they are equal to one another because they are both equal to 90. Okay, so now we've nailed down one angle. Now we have to try and find something else. This angle over here at P is called a common angle. And the reason that we use the word common is because it's inside both triangles. It's inside the yellow triangle and it is inside the purple triangle. So angle P is common. Sorry, not equals, is common. Okay, so now we have two pairs of angles. Angle P equals angle P, angle R1 equals angle S1. What's left over? It's going to be this angle over here, Q2 in the purple triangle, and it's going to be angle T in this triangle over there. Because the angles of a triangle add up to 180 degrees, it means that these two angles have to be the same size. So we're allowed to write that angle Q2 equals angle T because of the angles of a triangle adding up to 180 degrees. That's the appropriate abbreviation. So now we have proved angle, angle, angle. There are three angles in the one triangle and they equal three angles in the other triangle. So now we can conclude that triangle PRQ is similar to triangle PST, and after that we are expected to write angle, angle, angle. Okay, so that's what I was explaining. The order of the letters is very important. When they give you the triangles like they've done in question A, they are telling you that angle P, the first letter, and the first letter go together. Angle P is the same as angle P. They're telling you that angle R in the one triangle is the same size as angle S in the other triangle. And it also means that angle Q in the first triangle is the same size as angle T in the second triangle. Okay, so that's how we would go about proving similarity. Okay. It equals it because the angles of a triangle add up to 180 degrees. Okay, Bradley. So in other words, if you have proved two angles, which we've already done by other means, we can conclude that the remaining angles of the triangle must be equal because the angles of a triangle sum up to 180. So P and R1 and Q equals 180, and P and S and T equals 180. So if P is the same and R1 and S are the same, what's left over? Q2 and T must also be the same. That's where it comes from. Okay, but you can only use that as your third reason. Okay, good. So I'm seeing some words understood, understand. That's wonderful. I'm so pleased to see that. Okay, the second bit. Okay, so now the others that have had a chance to do a triangle PAB and ABC, how's that gone for you? Are you finished? Thumbs up, thumbs down. Are you finished? Good, Lesedi, I'm so pleased. Okay, that's good to see. Omogolo's done. Okay, that's all right. We're going to do it together anyway, so don't stress about it. Okay, lovely.
Well
So
done,
nice
that's
to see
good
these
job.
thumbs ups. Okay, good job, everybody. Okay, so I promise we are going to come back to this, and I will give you guys an opportunity to ask some questions. What did I do? I copied it. All right, so I can just delete that quickly. We'll come back to that now. So now I want to show you how to do the second part, right? This is now part B. So in part A, we proved that the triangles were similar. Now in part B, this is where the order of the letters is so important. Remember, I was saying that the first two letters in the one triangle and the first two letters in the other triangle are corresponding sides because they are opposite angles of the same size. Okay, so side PR is opposite angle Q, and side PS is opposite angle T, and we know that Q2 and T are equal to one another. That's why they are corresponding sides. So this is what we write. PR, first two over first two. So PR over PS is equal to second two over second two. So RQ over the second two are ST equals first and last PQ over first and last PT. And our reason for this is corresponding sides are in proportion if triangles are similar. Okay, so this is a statement that we always need to make after we have proved similarity, because now after they have asked us to prove the triangles are similar, in question B, they are asking us to write ratios or proportions about the sides. So now the easiest thing for you to do is go and get a highlighter. They want side RQ, so let's highlight RQ over here. They want side PQ, so there's PQ over there. Let's go and find PQ, that's this one over here. Okay, then we're going to go back here. They want ST, so here is ST over here. And then the last one that they want, let's just change our color quickly. We'll go with that nice soft little pink color, PT, that's PT over there. Can you see that these make a proportion? Here is your proportion. Okay, so what this means is that RQ over ST is the same as PQ over PT. What they are doing here is they are comparing the numerators with one another and the denominators with one another. So we are allowed to do that. We are allowed to say, well, therefore, the ratio of the numerators, RQ is to PQ, is the same as the ratio of the denominators. Why does this work? It works because if we think of this in numbers rather than letters, 1 over 2 is the same as 5 over 10. So what I am writing over here is the equivalent of 1 is to 5. I'm comparing the numerators, is the same as 2 is to 10. I'm comparing the denominators. That's why I'm allowed to do that. Okay. All right. How does that feel? Thumbs up, thumbs down. Is that making sense?
Let's vote, my people. There we go. There we go, Musanda. Okay.
Okay. Oh, that's good. That's positive.
Really good.
Nice, guys. Well done. Lovely. Okay. Okay, so most of you are saying thumbs up, which is really, really positive to see. That's brilliant. Are there any questions? Is there anybody who wants to unmute and ask a question? You're more than welcome. Lovely. I love all those thumbs ups. That's excellent.
Don't forget your screenshots.
Okay, thanks, Sasha. Thanks, Alway, too. Okay, so that's how we would do part B. All right. Then over here, part C, what does the dot mean? What are they asking us to do here? And again, this is a concept from when we first spoke about proportions and proportionality and Descept theorem. What have they done here to create this? Can anybody remember? Lovely, lovely, beautiful. Okay, they have multiplied. They've done cross multiplication. Okay, so this over here is like your framework. I'm just going to draw another. This is like your framework. You only have to write it once. Okay, and then everything else comes as a result of that. So now again, in question C, we are referring back to this. They want PR, there is PR. So PR over PS. Okay, what other letters do they want? PQ and PT. So that would be the last bit over here, equals PQ over PT. So now what I've done is I've made the first two fractions equal to the last, and I've ignored the one in the middle. And now I'm going to cross multiply. Okay, so I'm going to multiply PT and PR. So that's going to give me PR times PT is equal to, and then I'm going to multiply PQ and PS. And that's it. Okay, so that's just another manipulation that I'm allowed to make. Okay, I can cross multiply my portions, and then I can write my answer as a product. Okay, how do we feel about that? Are we feeling good? Is that making sense? Just again, thumbs up, thumbs down. Any questions? Yeah, it's very good. It's very quick. Oh, good, Shanine. Thank you. Cool, Daneo. Lovely. Sure, Pumalela, no problem. In Nhlanhla, don't worry. This is gonna become easier with time. We've just got to keep practicing it. The first time we hear things, it's often not simple. Okay. All right. So now what I'm going to do is I'm going to give you guys an opportunity to practice this yourselves, right? Those of you that have already done triangle PAB, similar to triangle ABC, you are welcome to go on and do part B and part C, and then we'll mark it and we'll move on from there. Okay, so I want everybody to have an opportunity now to first prove congruency. And then I'm going to give you 5 minutes for that for part A, and then we'll just check, and then we'll do B and C together. Okay. All right. Off we go. And if you've got any questions, Yolanda and I are here to help.
Definitely, my people. Let's go. 5 minutes is. Emihle, I hope you are working. Ayanda, I hope you are doing some good things. Guys, I can't see your faces, so that's the best that I can do. Simnigiwe, shouting out to you. Tina, shouting out to you also. Guys, I love all of you. You're like 91 of you. Yes, Emihle, thank you. Just making a little bit of noise so you guys can focus. I'm not sure how, but you'll make a plan. Hoping you're focusing. Sasha, Amanda, Zetsu, Lee. Also, oh, we have another Lee.
We
Yeah.
cool.
spelled differently, L-E-E.
Oh, so it's just spelt a little bit differently, but it's the same thing.
Yeah. Zizi
Maybe
says
that maybe
sometimes a last name.
that Lee is a boy.
Oh,
It could
oh,
be, or not necessarily, but it could be.
I see. Let's go, guys. Remember, if you have any questions, we are here while others are busy trying to the questions. And Teacher Lee, of course, she loves us. She's giving us clues over there, highlighting some important things. Hint, hint. You need to get that one. Garabo, I see you. I see you. I hope you're working. And no pumelelo. It's typed on the cards also. Let's go, guys. Amohelang, you can take a screenshot because I see you are like in and out. Take a screenshot to work things out first.
Yeah, so PA, and sorry, what were you saying? Let's have a look at that again. So PA and BC, they're parallel sides, but they're not corresponding sides, non-Pomelelo, because PA is opposite B1, side AB is opposite angle C, which is the same size as B1. So PA and AB are corresponding sides. No problem. Okay, so we've got 1 minute to go, and then we're going to talk about the answer to A. Okay, so it's time to talk about A. Hopefully you guys have been able to do this. What I'm going to do is I'm going to give somebody, one of the students, an opportunity to tell us what you wrote. So is there anybody that's feeling confident that wants to share their answer? And I'd love it if you could unmute and talk. And even if you get it wrong, don't stress, we'll help you. Anybody want to unmute and tell us how to do this?
Hi, everyone.
It does, Sarah, quite right. We've just got to think of a reason. Okay. Anybody feeling brave and want to have a go? Cool, Bradley, go for it. Awesome.
Sorry.
Sorry.
Hello, hi.
Is it
And
you,
then-
Omokolo?
Yes, it's me again.
Go for it. Okay, go for it, Omokolo.
in triangle PAB and triangle ABC. First,
Mhm.
I show you the triangles in my book, like Kids 5. You show them, then I read the instruction. In diagram, PA is parallel to BC and B1 is equals to C. Prove that triangle PAB is congruent to triangle ABC. First is B1 is equals to angles. Angle B1 is equals to angle C.
Lovely. Reason?
It's given.
Beautiful. Keep going. I love what I'm hearing.
Then angle A1 is equals to angle B2.
Excellent. Reason?
Alternating angles. Then PA is parallel to BC.
Beautiful. Oh, that is just gorgeous. Keep going. Very nice.
Wow.
Angle A2 is equals to angle P.
There we go. So angle P is equal to angle A2. And what was your reason here, Omokolo?
Angles of a triangle end up to 180 degrees.
Lovely. Oh, that is just fantastic. Well done. That's
Wow, well
absolutely brilliant. Perfect.
Therefore, triangle PAB is congruent to triangle ABC, angle.
Okay, so just remember it's similar, not congruent, but other
Yeah.
than that, well done, Omokolo. That was absolutely fantastic.
Well done.
Okay,
Wow, it's
excellent work.
guys.
Okay, I'm super, super, super impressed. Very, very, very good. Well done. Beautiful. Okay, so now that Omokolo has done that bit first, is there anybody, I know Bradley, you had your hand up. Bradley, do you feel brave enough to tell us what you did in B?
Yeah,
Go for it. Cool, Bradley, go for it. What did you write?
B, I said PA over AB.
Stunning, keep going.
Is equals to AB over BC.
Wow. Awesome, awesome, awesome. Love it, love it, love it. Keep going.
Then it's equals to PB over AC.
Beautiful. Equals PB over AC. Fantastic. Okay, and what was your reason here, Bradley?
Corresponding sides in proportion.
You guys are just amazing. Excellent. Oh, I'm so
Well
excited.
done.
Excellent, excellent. Okay, and now, what did you do next?
Since they wanted the size of PA in over AB, so I say PA over AB is equals to PB over AC.
Fantastic. Okay, and then you said, all right. So, numerator, PA, is to denominator, is the same as
PB.
numerator is to denominator. Bradley, that's fantastic.
Ah,
Oh, you
well
guys are
done.
just amazing.
Woo.
I'm so pleased. Well done. That's beautiful. Okay.
Big screenshot, guys.
Yeah, screenshots. So we're going to do the second
Screenshot.
part now. Tundle went to quite a lot, actually, because when you are being asked to prove similarity, this would probably be out of 3 marks. So it would normally be 1, 2, and then sometimes there's a mark here as well. Otherwise, there might be a mark over there. So yeah, probably 3 marks for something like this. And then here there would be a mark for that, a mark for that. And then for doing this. So yeah, that's out of 6 already. So yes, quite a lot of marks. All right, so now that we've had all these fantastic responses, anybody want to try C for us? Who would like to do C? Sasha, do you want to do C? It's a pleasure, Tandalwe, too. Okay, anybody willing to try C for us? Don't be shy, guys. Even if you get it wrong, it doesn't matter. No one's William, go for it. Hi, William.
Hi.
Hi.
Here they asked us to prove that AB times AC equals BP times BC. So what I had done was I wrote AB over BC.
You wrote AB over BC. Okay, all right, so that's the middle one. Okay, so you wrote AB over BC. Cool. So William's getting that from the middle here, guys. Okay, is equal to?
PB over AC.
Fantastic. All right, and then from there, what did you do?
From there, I cross multiplied to get my answer.
Fantastic. Absolutely fantastic. So cross multiplying here, getting AB times AC, and then cross multiplying over there and getting BP, PB. It really doesn't matter the order of the letters times BC. That is just amazing. Well done.
Yeah,
You
well
guys
done.
are brilliant. Absolutely, absolutely brilliant. So 3 stunning, stunning, stunning answers. I'm so pleased. Okay. Yes, Bradley, I'll scroll up just a little bit. There we go. Does that help? So yeah, please take screenshots, guys. And once we've done that, I would like to give you just a little bit of homework. All right.
Ma'am, can I ask?
With pleasure, Omaholo, go for it.
At number B, step number 2.
Mhm.
Why
Yes.
did the person use PA over AB?
What he did is he looked at the letters that they wanted. So use a highlighter. Okay. Oh, man. Stupid thing. Hang on. Let me just get rid of that. Use a highlighter or moholo. All right. And highlight the letters that they want. Okay. So highlight PA over here and then highlight that PA in the same color. All right. And then over here, get a different color highlighter. They want AB over here. There's AB over there. Then get another color highlighter. So let's use a darker pink. There's PB over here. There's PB over here. And then if I change the color of my highlighter and I use a blue one, I've got AC over here and I've got AC over there. That's why.
Wow.
Okay,
thank
so
you.
that's what Bradley did, is he used the first fraction and the third fraction. So what we can do is we can make combinations, Omaholo and everybody else. So we can make a combination of the first and the third fraction, or the second and the third fraction, or the first and the second fraction, because they're all equal to one another. And then we can ask you to do various manipulations. Okay, but that's where we got it. That's where he got it from. Okay.
Yes, ma'am.
Okay, awesome. All right.
Nice, my
Good,
people.
Lissetti. I'm so glad. Are there any other questions that you guys want to ask before I show you what the homework is? Anything else that we've been through? No, Angelique, because you have already provided your reason when you wrote the corresponding sides in proportion up here. Okay, so provided you've written your corresponding sides in proportion, you've written these 3 fractions, and you've provided this reason over here, any further manipulations that come from that, you don't have to provide a reason because you've already put a reason there. Okay, very good question, Angelique, actually. Sure.
Guys, don't look out. We have polls to do, my people.
Yeah, Martha, I don't have a formula sheet to hand at the moment. None of the things that we're doing here would be on a formula sheet anyway, unfortunately. All right, but I can include it in the next lesson, but it's not going to be useful to you now. Okay, all right. So I know that Yolanda wants to do the poll. What I just want to give you is an opportunity to practice some more stuff. Okay, so here's a screenshot. Okay, it's up to you. I'm giving you 2 questions. You don't have to do both. Maybe you just want to do the first one, right? But either way, it's an opportunity for you to practice what it is that we've done this lesson. Question 3 is a little bit easier than question 4. And again, I'll show you the answers to that at the next lesson. So take a screenshot if you want some to practice.